We're going to learn how to graph piecewise functions. So piecewise functions are just graphs that are made up of pieces of a whole bunch of different functions. So let's take a look at number 1. So we're going to start off with this first one, which is x squared. So we're first just going to graph this. Now x squared we know is a quadratic function, and it's just the parent function. So we have 0, 0, 1, 1, 2, 4, 3, 9. And the same thing on the other side. So negative 1, 1, negative 2, 4, negative 3, 9. And there are no transformations that have happened here. So we can just draw our function. This is the x squared graph. Now what's different about this is that we now have a specific domain. So for this graph right here, I only want to draw this graph when x is less than or equal to 1. So x is 1 at right here. So if I want all my x's, I want this to only exist when x is less than 1, so I only want this side of my graph, which means I'm going to erase everything on this side of my graph, because I only want to see this graph for when x is less than 1. And notice how there is no equal to sign, so this is going to be an open circle, because it's not included. So exactly at this one, I'm going to draw an open circle right there. So this is the first piece of my graph. It's x squared, but I only want it to look like x squared when it's 1 or less. So now I'm going to trace this in pen, because this part I know is for sure. This is my first piece of my graph. For the second piece of my graph now, I'm using y is equal to 3. So y is equal to 3 is actually just a straight line. Right at the y value is equal to 3. For this one though, I only want this to exist at x is equal to 1. So only exactly at 1 do I want this to be here. So on both sides, I actually don't care what's on the left side or on the right side. All I want is 1 point at 1. So again, now I'm going to do this in pen. So this is the second part of my graph. So it's only 1 point because it's only at x is equal to 1. That's the only x value this is true for. Now we have one last piece of our function. So this was number 1. This is number 2. I'm going to label them just so you can see. 1, 2, and we're going to finally do number 3. So this is a line. We know the parent function is linear. mx plus b. Our b value is 6. So we know we're going to start at a y-intercept of 6. And our slope is negative 1 over 1, so this is rise over run, so we're going to go 1 down, 1 to the right. So starting here, I'm going to go 1 down, 1 to the right, 1 down, 1 to the right, 1 down, 1 to the right, all the way in both directions. So this is my line, but just like with our other ones, we have x is greater than 1, so we only care about this at 1 and greater, so only on the right side of 1. So I'm going to erase everything on the left side, and because this is a greater than, it's not equal to, this is going to be an open circle as well. So this is going to be an open circle, and then the line keeps on going down here. So here are the 3 parts of my graph. Here's my piecewise graph. I have 3 pieces of my graph. 1, 2, and this is number 3. I'm done with this graph. So let's look at our domain. Our domain is our x value. So on the left, this arrow means I keep on going to the left. So this is actually going to be negative infinity, and it keeps on going to the right as well. It keeps on going. So this is also infinity. So negative infinity to infinity, or all real numbers, same thing. For a range, now we're going up and down. So down here, the lowest point it gets to, this arrow keeps on going down, so also negative infinity. Highest point it goes to, so it reaches everything in between and goes all the way up to positive infinity, so again, all real numbers. Now let's take a look at one slightly more complicated. Let's look at number 2. So for number 2, let's start off with number 1 here. So this is a line. We know this is going to be linear. our mx plus b. We know our b value is -1. So -1 is the starting point for my graph. And the slope is -2/1. So this is 2 down, 1 to the right. So I'm starting at my y-intercept of -1. I'm going to go 2 down, 1 to the right, 2 down, 1 to the right, 2 down, 1 to the right, and same thing in the other direction. So now it's 2 up, 1 to the left in this direction. So this is my line. This is number 1. My first piece of the graph. And so my domain for this section is I only want my x to be less than or equal to -2. And so because of this equal sign, this is going to be a closed circle. So at -2, this is the point where I'm starting at. This is the closed circle, and I only want what's less than it, so I only want this direction. And I'm going to erase everything else on the right side of it, because that part is not in our domain. So again, now I'm going to go over this in pen, so I know that this is the section I'm keeping. Everything on the right side's gone. Okay, let's take a look at number 2 now. So this is clearly a square root function. Square root function, my parent function is 0, 0, 1, 1, 4, 2, 9, 3. And for number 2, the square root function, there's 2 transformations that are happening here. This negative affects my x's, so it's a y-axis reflection. And then I also have a -2 inside of my square root, so that means I'm going to be going to the right 2 because it's your inverse. So the one we're going to do first is our y-axis reflection. So I'm going to reflect it across the y-axis. So instead of opening to the right, it's now going to go to the left. So 1, 1, 4, 2, 9, 3. So I can actually erase these points since I'm only looking at this one now. I'm going to move all these points right 2. So here's my new point, here's my new point, here's my new point, here's my new point. I'm going to connect them, and this is the graph for number 2. And now I'm going to again use my domain to figure out what part of my graph I'm going to keep. So I want it to be from -2 to +2. On this side, this is going to be an open circle because there's no equal to. This is going to be closed because there is an equal to. So at the -2, I want this to be an open circle. So I'm going to erase this and replace it with an open circle. And I want it to be in between -2 and +2. So I'm going to erase everything else except for the part that is in between -2 and 2. So see how here's -2 and 2. Everything in between stays. I erased everything on the left side, and there was actually nothing on the right side, so you didn't have to erase anything there. So this one is open, this one is closed. Okay, now we have one last one to graph. So I've done number 1. This was number 2. And now let's do number 3. So 3 is again a square root, right? So we're starting with the same parent function. 0, 0, 1, 1, 4, 2, 9, 3. But this time for number 3, the only thing that's happening here is that it's been moved right 2. So each of these points has been moved to the right 2, right 2, right 2, right 2, and it looks like this. And my domain is x is greater than 2, so I want it to have a 2 and then be greater than that, and so only on the right side. So for this one, there's actually nothing you need to erase because there's nothing on the left side, right? So everything's already on the right side, so this is great. And even though this is technically an open circle, it is on top of our closed circle from number 2. So an open circle on top of a closed circle is going to just look like a closed circle. So then this is my graph. This is my final graph. Number 3. And now we just have to find our domain and range. So domain starts at -infinity, goes to +infinity, so, or all real numbers. Range is different though, because in this one, the lowest point is right here, which is a y value of 0. It's a closed circle, so it's going to be a bracket, and then it's going to go up forever to positive infinity. So that's my range for this one. And I'm done with this problem.